All right, thanks everybody for joining after our fall break. We have a lot of talks scheduled for the next couple of weeks that'll take us through the start of next year. And we're happy to have some good colleagues from the University of Missouri here today to go over a new project that they've been working on. It's an online learning platform for Cloud and DevOps curriculum, and all three are going to be speaking. So we have Prasad, Songjie, and Roshan. And Prasad is going to kick us off, and then we'll go into a little bit of a demo, and we'll be able to have some time for questions after. So I'll turn it over to you, Prasad.
All right, thank you, Jason. Good afternoon, everybody. Happy to see all of you. I know some of you, it's great to connect today. And I'm excited to talk about our project we've been working on for a few months now, I would say starting from the beginning of this year. And the goal has been to find a way to have students learn about Cloud and DevOps tools and curriculums and ideas, and really create some kind of a engaging platform to learn. So an online platform. And the goal is that they just don't only learn the tools, but really see the relevance in the context of real world applications. And that's how we feel they can take the learning further. So in the talk today, that I'll talk a few things. I'll be joined by Songjie and Roshan, who will give us more demos and details on some of these curriculum. And the goal is to have you all try it out. So we'll show you links and ways to engage with us to try these lab exercises out. So just to get started, like why do we care about Cloud and DevOps? And as you all know, the Cloud and DevOps technologies and tools are changing everything what we do today in the cloud with applications, how we scale applications, how we build applications, how we maintain them. And they are fantastic in terms of bringing development teams, operations teams together, streamlining processes, and most importantly, automating a lot of the software infrastructure to keep up with all the dynamics of running large scale applications. And obviously other benefits are we can deliver new features to users quickly and have applications continuously be evolving to meet different kinds of needs of users. And then all of that evolution can be done in a very stable environment. And people working in these applications or in the infrastructure side don't need to do some of the nitty gritty, but they can focus on innovation and get on with things that are more fun. So Cloud DevOps has really taken off. It's there everywhere, everybody's using it, but the learning curve is kind of a little hard. The reason is that there's so many tools and so many ways to do these things. And the ecosystem here, you can see this is just a sample. Students who are starting off, have a hard time, knowing where to go, what infrastructure is available for them to experiment with these, and again, what concepts are relevant. So the way we see it is this is an amazing journey for somebody who wants to get into this area, but it's a little bit harder to really get started because of all these issues of, what's the content, what is kind of the infrastructure I can try to run this on, get feedback, really know if you're learning and how you're making progress. So all of these challenges, are something we want to help students with through our project. And the goals we have set aside is that we want to make this application inspired. So you can learn a lot of knobs and tools, technologies, but the idea is really that you need to be able to apply it in a real world context, in a real application. And how does that work? And that's where you appreciate really the learning of what the technology or the tool can offer. And you can actually go off and become a practitioner with those tools and technologies. So we want to really give that application context along with the tools and technology training. And we want to make it free. As I said, people have a hard time finding infrastructure, finding the right kinds of exercises or a community or an ecosystem to go practice. And we want to have everybody have a chance to do this. So many of you on this call, cyber infrastructure engineers and software developers, but even faculty, students at universities or anybody online, they should be able to access our platform and learn about the technologies and really its relevance to real world applications. And so we're able to do this with collaboration and funding from VMware. Really thank VMware for that support. And we're using a lot of NSF clouds and also public clouds that are given freely for education purposes, like the AWS Educate. So the labs that we want to talk to you today are accessible on NSF. Nautilus is one of the clouds we use. Genie is another. AWS Educate is the Amazon version. But the hope is the lab access will give an exposure to a wide range of technologies that are related to cloud and DevOps, a wide range of platforms, and a wide range of applications. So that's our goal, is to really get that beginner experience in a very rich way to start learning all the advanced concepts. And last but not least, we want to have a platform where students, when they sign up, it's easy to sign up. So we can show you that just with a GitHub account, you're able to log in, enroll in a course, do the course, have a pre-assessment, post-assessment, and then you can see how you have learned, if you are really meeting the goals of the learning and how you stand in comparison with all your peers. And we have this platform so that you can have different instructors add new courses, and they can also track their students. So we've created a platform that helps everybody collaborate in terms of both instruction and learning. And why did we go with application inspired? And as I said, the number of tools or the knobs in all of those tools are too many. And what the goal here is, we want to get students excited, especially those who are starting off with doing all these technologies in cloud and DevOps, to focus on the big picture and give them enough of a preparation so they can have the imagination, right? It's just not the technology ability that's important, like Wilson says in this famous TED Talk, but it's really how they can imagine how these technologies fit into different real world application contexts. So that's why we want to make it applications. But I think that's what makes us unique in what we're trying to do in this effort compared to many other things you might find on YouTube or otherwise, right? So we want to really, inculcate that passion about the whole, possibilities with cloud and DevOps tools and technologies. So just to get into a little bit of the details, what we'll show you today and invite you to use and give us feedback is these lab modules that span a number of interesting challenges today we have in cloud and DevOps. So one of the challenges, how do we orchestrate containers for video processing? How do we do cloud networking for cyber defense? How do we bring edge and cloud infrastructures and federate them for trusted computing to do a lot of data processing? And also, if you're doing automation of data pipelines for knowledge discovery, how do we deploy these cloud and DevOps tools? So each of these challenges are kind of very relevant to many projects that are going on in our community today. And all of them represent a number of concepts that are underlying, right? With microservices and monitoring and creating clusters and apps across multiple clouds. So we want to basically provide exposure to some of these main concepts, hands-on exercises, but then show them how we can address real challenges we're facing today in all of these areas. So in summary, here are the 4 labs we'll talk about today that you can access, and we've given instructions, and we'll give you a demo and more information also following in this talk. So the first one is about how to use Kubernetes. And it's in the context of an application, which is a visual cloud computing app. And the second one is about software-defined networking with cyber defense. The third is KubeEdge with edge computing for a bioinformatics app. And the last one is continuous integration, continuous deploy CICD, which is an important concept for deploying code. We'll do it with Jenkins in the context of some data-intensive web apps. And in all of these, obviously, there are some prerequisites that we expect the students to have. And we're trying to make these available in as many cloud platforms as possible and as many variety. Obviously, the more variety we have, which makes us harder to manage students doing many of these cloud platforms. But we're trying to streamline most of the platforms, most of the exercise on the AWS platform. But we have actually the capability to deploy them on other open platforms or public cloud platforms. And so last part of what I want to say is, as I said, this is a very exciting new field. It's very vast. It's very, much rapidly growing and changing. And we think what we want to do is, inspire the students to get started in this, give them some infrastructure, give them some good resources, and help them set the application context. And it's not about all the knobs in these tools that we want to do, right? It's not about if you want to go on an adventure. You want to build a ship, and you don't want to have people have only tasks and work, right? We want them to really enjoy this endless immensity of the sea. So we want to make sure that they get started in this journey of Cloud and DevOps with our modules. So with that, I will let Roshan do a demonstration of how you can actually use these lab modules. And then Songjie will go through some of the details of each of these lab modules to show you, what we have planned. And the hope is all of you, please, will try it out and also give us feedback to make this better. And so we just started the outreach effort on this. So we've been in development mode for a while. So I know many of you are really amazing users and who can give me really good expert feedback. So I'm hoping you will try this out and give me some feedback, and give Roshan and Songjie also some feedback. Thank you. So go ahead, Roshan.
Yeah, thank you so much, Dr. Calyam. Let me share the screen now. Okay, does everybody see my screen?
Yes, we do.
Yeah.
Okay, good. So welcome to the Mizzou Cloud and DevOps web portal. As most of the information Professor already provided, we have a few modules that are built around Cloud and DevOps that I'm going to demonstrate today. This web portal is flexible in terms of education catalog. It has unique focus on technologies, platforms, and use case applications. All of these, as mentioned, are cloud hosted and easy to use. The features that we would like to mention is that the real application scenarios, the emerging technologies, and application inspired learning. When I go to the Cloud DevOps tab, there is a brief introduction to what Mizzou Cloud and DevOps is, and all these publications that you can see here are actually the research work that these labs have been built upon. And the education catalog shows the different modules. There are 4 in total. There's a brief overview of each and every modules here. The team, we are a team of 4 in developing this portal and also the curriculum. And specifically getting into the actual like the lab work or the portal, one would need to have GitHub account. There is 2 different roles in our portal. One is of a student, and the other one is of an instructor. So I will initially show you how students would view this platform in terms of like how they would view their dashboard and how they can begin working on it. So let me quickly put my credentials here to start demonstrating this. Okay. So the OAuth would land me to this page where I can, where as a student, I have 3 different tabs to look at. The home tab gives the overview, like cards of different modules, as you can see right here, the different tags of what they are about, the technologies being used, and then the cloud platforms, and so on and so forth. They also have time to complete. And simply clicking on view details, one would get a little bit more information about what this lab is and what they could learn off of this. Initially, it's enroll because I've already enrolled. I wanted to also show you the functionality of how to unenroll and restore with the lab if you would feel like it. So in the My Courses tab, you could see all the labs that you've already been enrolled in and completed. Let me quickly go on and show you how I could restart this lab by just clicking on unenroll, and there is a few alerts that it throws that I say okay to, and then when I go back to home, now I can view details to say enroll. And again, it's going to confirm that I've been enrolled, and then I go back to My Courses tab and then continue from here. So the first page is getting started, shows the purpose of the lab, the goals and outcomes of it, the different references, the resource materials that you would benefit a lot from using for this particular lab. And there is a general guideline of how to complete the lab. And then again, every lab modules have some sort of rewards based on the grade that you get in your assessment. Yeah, so this is the main overview of the lab. That is the Kubernetes with Visual Cloud Computing application. And when you go to the lab exercise, you could see there is this initial, like a small survey that you can kind of give an idea, to tell the system that if you're aware of a few technologies. For example, have you worked with Kubernetes? Have you used Nautilus platform before? Or like if you've used Docker containers before? And when you do that, then you would be taken to this PDF, which is actually the instruction manual for this particular lab. And when you think Songjie will provide more information about these labs, but this is basically where you would walk through each and every items of this, and then finally say you complete the lab. And then once you do that, then the assessment is enabled, where you have a bunch of questions that you can answer to, and then you're graded. So let me just quickly put some answers here. I'm just gonna put a few correct and incorrect answers, and then show you how this thing works. Okay. Perfect. So yeah, once you provide this information, you have a score that is provided to you. And the third tab that we didn't talk about yet is the progress tab, where every student can go in and see the progress they've made in terms of every single lab modules, and also get to see their ranking, any sort of medal that they receive. And there is also a tab where, also a link where they can see the peer standings. So let me look into this Kubernetes one that I just did. So it will show or the students' rank amongst the other peers that have taken this lab. And I think this kind of is the overview of how a student will look into this. Give me a few seconds so that I can change my role to instructor. And again, if there is any questions, I'll take it. You can ask me. Just wanted to say that. Now, this is the instructor dashboard. You can see there's a few more additions and reductions of the tabs. I think it's more than student. Basically, the home would also allow instructors to go and view the different lab modules, the details and information as such. There's a request tab whenever somebody is trying to access this portal. There is an email sent out to for example, for now there is this email, and then there would the person who has this email will allow or disallow access to some of the requests. And then again, like Professor mentioned earlier, there could be where we can add new instructors. So if we treat an instructor, then there would be more than one instructors as we see it fit. And then there is a course editor. We talked about this a bit also, where there is an out-of-the-box functionality where instructors can go in and create courses based on some of the information that they can provide, like some details and stuff like that. And there's the students list where there are students. You get to see an overview of lab completed by some students, and like how many have completed, or like their general information around different labs that we have in this portal. And the last tab is student progress, which is the telemetry of the overall statistics and everything that is happening in the web portal. We try to grab information such as number of enrollments, number of grades, and then rankings, and so on and so forth. The initial view provides an overview of every courses. That's the all courses right here, which we see in terms of how many students were enrolled in what month and in whatnot. And when we want to go deeper into the labs, we can click one of these labs here, where we can see that there is student based on score, that there is a gold, there's silver, there's bronze, and there is when an award is granted, provided. And then there is peer ranking, the instructor can view, and there is also the student average, like what's the score basically. And yeah, so this is like Professor mentioned, we would be very happy to take in any feedbacks around how this is built so far, how we can improve and everything. And the last but not the least part is as soon as you get inside the DevOps platform, the portal, you can see this link here says join us on Slack, which will allow you to click and then redirect you to our Slack channel, which is Mizzou Cloud DevOps, and you can be a part of it, ask questions, and even consider providing feedbacks or generally discuss about this portal. And this is the end of the demonstration. Thank you. And actually, yeah, now Songjie will talk a bit more about the rest of the labs.
Sure, thank you, Roshan. So in the rest of the presentation today, I'm going to provide some high-level introductions of all the learning modules in our learning series. So in this overview, I'm going to provide some information about what the DevOps technologies we're learning in each of these labs, and then which cloud platform that we use to experience these DevOps technologies. And then as well, we provide some real research-based use case applications in each of these labs, just based off of our research projects. So just to showcase to the users how we could leverage these DevOps technologies and the cloud platforms, how do we integrate these into our research applications, and show how everything's working. So here I'm showing the first lab, the Kubernetes on PRP Nautilus. And then in this lab, we're teaching users how to learn the basic knowledge and skills about Kubernetes. And then we are doing this on the PRP Nautilus platform. So in this lab, we have a research-based use case application, which is called visual cloud computing. We basically do image and video analytics using a deep learning neural network. So Kubernetes, as most of you are either aware of or maybe expert on those, is a very popular open source system to deploy container-based applications. So the Kubernetes allow users to deploy their applications with the high availability, high portability, and high resilience, and all those kind of features. So it's many people and researchers, they prefer to use Kubernetes to run their applications now. So the cloud platform, PRP Nautilus, is a large Kubernetes-based platform currently supported by NSF and running on the Pacific Research Platform here. So Nautilus is a platform that has a large amount of resources for running Kubernetes cluster-based applications. It has several hundred nodes with thousands of pods available for researchers to deploy their applications. And it runs the most updated Kubernetes versions with lots of plugins and tools to help researchers to deploy their applications. So, and also, as Professor Calyam mentioned before, we also have this lab available on AWS because on AWS, people can learn some different things, such as they're going to learn how to deploy a Kubernetes cluster on themselves. And then there are some other technologies which are different from public cloud compared to the research cloud. So the visual cloud computing application here we're showing is a image and a video analytics pipeline. Basically, we use this application for processing, like for example, drone-based videos to track objects and to recognize and track objects in the videos. So this application leverage deep learning algorithm using a deep learning neural network called DarkNet. So the DarkNet leverage YOLO-based algorithm to detect objects with the COCO data sets in there. For this application deployment, we created a client and a server, which will be deployed on the Kubernetes cluster on Nautilus or AWS, and then these pods will be running the application components in there. So once we feed the videos into the client will send the image frames to the server, and the server will run the deep learning neural network to process these image frames. So at the end of this lab setup, the user will run these pods in the Kubernetes cluster. And then we're showing some exemplar output of these application. So on the right-hand side, you can see the deep neural network is outputting the detected objects in the video frame, which is shown on the left-hand side. And then the output shows the types of the vehicles in there and the numbers of the vehicles, and along with the confidence levels of these recognition. At the end of this lab, they can collect all these data and use them for their research purpose. So in this lab, we will guide the students to get familiar with the Nautilus platform, and they will learn some fundamentals of Kubernetes, as we list here. And then during the lab execution, they will deploy a stateless application, the guestbook application, so they can try to see how this web front and the MongoDB can work together on the Kubernetes cluster. But at the end of this deployment, the data will be not persisted, so they will lose everything. But at the end of the lab, we'll deploy this VCC pipeline, and so they can the users can learn how to deploy these video analytics pipelines, and then use the use the persistent volumes to store the output results permanently, unless they want to delete it. And they can also share the data between different pods and different collaborators. So in the lab 2, we have a software-defined networking deployment. So in this lab, the users will learn how to set up software-defined networking on public cloud. So in this case, we're using Google Cloud platform. And then so the software-defined networking will be created using virtual extended LAN on this platform. And then we will use a research application called Doulos, which is a cyber defense system that use pretense-based algorithm to detect and defend various cyber attacks. So software-defined networking basically is an approach to create and manage network connections dynamically and programmatically. So this allows users to manage the network connections between inside a network, and to be able to control the networking between different nodes. So the software-defined networking currently is not it's not a like traditional like software-defined networking is not feasible on public cloud because they don't allow users to manage their physical switches. However, in this lab settings, we are creating this software-defined networking use VXLAN to be able to extract the network connections on top of layer 2 and layer 3, so so users can create their virtual network to experience SDN settings. And then, oops, sorry. So for the research application, the Doulos is basically a defense by pretense mechanism, and then to detect and defend from multiple target attacks. So in this case, we're dealing with some DDoS attack, some advanced persistent threat attacks, and cryptojacking attacks. So in the Doulos topology setup, we have a controller that is running the SDN controller, and then we have a couple of virtual switches that is attached with some other nodes. For example, on one of the switch, we have users, both legitimate users and then malicious users, attackers. And then we have quarantine machines to really be used to trick the attackers when after the attack. And then we have another switch that has servers attached, and then we use this topology to mimic a real world attack and defense scenario. So in this case, we're using SDN-based networking capabilities to redirect the attacker once we detect the attacks. So the attacker is actually connected to the quarantine machine without doing any damage on the real servers. So after the level setup with the SDN, we are showing some output here. So on the left-hand side, we are showing the controller is running the frenetic programming interface that has that is showing the flow table with the two virtual switches attached. So the virtual switches will be redirecting the network connections between the nodes. And then on the right-hand side, we're doing some pin test showing we can connect from the tech node to a server node inside our topology. So with this network SDN networking up and running, the users can actually modify the flow tables using the frenetic programming interface to control the network connections between any of the nodes. So in this lab, we're just guiding students to learn how to set up the SDN network on a public cloud platform. In this case, GCP. So they're not limited to learning how software-defined networking works, but also under the hood, they are going to write up some scripts and programs to really create this software-defined networking to learn how everything works. So in this lab, we're also going to set up the doulos system and then use the doulos to control the network connections between the user nodes and the server nodes in the topology. So after this lab, the users can practice controlling their own network connections using the topologies. So the lab instruction is currently available on the Mizzou Cloud DevOps web portal. And the next lab is the KubeEdge lab. KubeEdge is a extension of the Kubernetes. Basically, it also creates a cluster, and then the users can manage the cluster nodes in there. And so what's different from the KubeEdge from the Kubernetes is that KubeEdge also adds edge computing capabilities. So the users can install the system on any of their edge computing devices, for example, Raspberry Pis or some other device. They connect to the cluster and they run computations on them. So in this lab, we also have a research-based application, which is called Volunteer Edge Computing with Bioinformatics. So with this application, we can see how we could run the bioinformatics workflow using edge devices through the KubeEdge system. So the KubeEdge is open sourced system, and it's based on Kubernetes that also supports containerized workflows. And KubeEdge basically has this device controller attached with the hubs on both the cloud side and the edge side. So these cloud and edge nodes, they communicate with message queue to be able to deploy like workflows and computations on the edge devices. So in this lab, we're leveraging both the Genie Cloud platform and AWS. So Genie is an NSF cloud that provides capabilities to run large research in networking and computations. So in this case, we can leverage the Genie Cloud to provide capabilities also in edge computing and AWS as well. So for this volunteer edge computing application, we basically use this researchers to better select and utilize computing resources both on their local and on public cloud platforms. So with this application, users can select the best computing resources that fits their research needs, but without spending too much on like costs. So with this application, we really leverage some existing frameworks. For example, we have the Pexas workflow management system and the HD Condor scheduler. Also, it comes with the PyGlide and Python client to submit a job to the edge nodes. Here we show some screenshots after the user set up the Kubernetes cluster. On the top left here, we show the users created a Kubernetes cluster with the one master node and a few edge nodes on their side. So once they set up this Kubernetes cluster, they can create a running like a pause on any of the nodes here. So what they need is just to create a YAML configuration file. So with the configuration file, they can specify their Docker containers to run and which node they're interested to run their workflows. And then on the right-hand side here, I'm showing some output. So once the users create the deployment and the pause on the cluster, they can see the job has been successfully submitted to the node that they specify in the YAML configuration file. So they can change this configuration file to run the workload on any of their edge nodes. And then again, at the bottom here, we're showing this bioinformatics workflow has been finished, and you can see how many tasks has been executed in the workflow, and then the total runtime that has been spent running on this. So to summarize this Kubernetes in this lab, we will guide a student to deploy a Kubernetes cluster on both Genie and AWS clouds, and then they will manage the cluster to set up the cloud node and the edge nodes within the cluster. And then at the end, they can deploy Docker containers to run bioinformatics workflows. And at the end, they can use these nodes to store the data and then to visualize how the performance are if they're using different computing resources or machines. Again, this lab instruction is also available in the Mizzou Cloud DevOps portal. So the last lab is CICD with Jenkins. So in this lab, we will guide users to learn about continuous integration and a continuous deployment. So in this case, we're using the Jenkins system to experience these CI/CD technologies. In this lab, we also have a research-based project. So in this case, the project is called Nokovit. So with this Nokovit application, the users can actually leverage artificial intelligence to be able to search and filter COVID-related information using like public databases, so they can pull some useful information to help with their research purposes. So the CICD technology has been really hot in the DevOps area to help researchers with their development and deployment purpose. So the traditional integration and deployment involves a lot of manual working on their code, and then to be able to push their code into repositories, and then compile and then deploy. So all these involves lots of manual access process, and then it's very time consuming and error prone. But with the CI/CD system, it makes everything much easier. So the developers can just push their code into a repository, and everything else is taken care of by the CI/CD system. So in this case, the developers can save a lot of time for the deployment. So in this lab, we're using the Jenkins system to help users to learn the CI/CD pipelines. Jenkins is an open source server, that provides a lot of capabilities and plugins to help building and deploying and automating their projects or pipelines. So Jenkins is a self-contained that can be used to deploy on any cloud platform, and then it can be used to build, test, and deliver and deploy any software. So currently, Jenkins also have capabilities to integrate with Docker and most programming languages such as Java. So in this case, in this lab, we're going to run Jenkins that has Docker and Java integrated. In terms of this Nokovit-19 application, so this application has been recently developed and deployed in our institution. And so this application provides artificial intelligence-based big data analytics. So we have a portal that users can log in to this application, and then from the portal they can perform some search and filter functionalities. So with these functionalities, this can help researchers to implement like a pandemic responses by making real-time decisions. And then the artificial intelligence is based off of published literature archives, and then also with the online available data sets and the tool sets, so the users can basically have access to those information and to help them with their research and research purposes. So we have some screenshots here showing that once we deploy the Nokovit-19 application on the Jenkins system, we can automate the deployment and build process. So we made this everything into a pipeline, and once we push the code into the repository, it can be built and deployed on the Tomcat server. So on the right-hand side, we're showing this the web portal of this Nokovit-19. So and the end user can log into the system and to be able to perform some search and filter functionalities to get the updated information in terms of COVID-related data sets. So overall, in this lab, we guide a student to create and deploy the Jenkins server on the AWS cloud, and then they can explore all the functionalities within the Jenkins and to learn the basics about this system. And then they will deploy some simple applications and to run some CI/CD jobs. At the end, they will deploy the Nokovit-19 to create the pipelines to automate the Docker-based workflows using Jenkins. Again, the lab instruction is available in our web portal on Mizzou Cloud DevOps. So here I have a summary of how you can get started with this learning series. The first is if you don't have one, you can create a GitHub account. So we will use this GitHub account to log into the Mizzou Cloud DevOps web portal, which is required, and then we will approve you to have access to the lab instructions on the portal. So the second one is we welcome you to join our Slack channel. So we have the links to join to the channel here, and then you can feel free to join us and then to have some discussion and provide feedback, as well as we will provide technical assistance in terms of all these learning modules in the Mizzou Cloud DevOps. And then the third one is we welcome you to register for a hands-on guide workshop. So our first workshop will be, the workshops will be like will be held for each of these learning modules. The first one will be on October 15th. So you can feel free to join us to do a hands-on on the Kubernetes technologies. And with this, we thank you very much. And do you have any questions?
All right, well, thank you, Prasad, Roshan, and Songjie. I don't see any questions in the chat room just yet, but if people do have any, please type them in. I have a couple to sort of get us started here. There's a lot of broad applicability for this sort of thing, whether it just be somebody who's trying to come up to speed to learn the technology if they already have a degree and they're on a project, or for students. Did you have a target sort of user in mind when you designed this, or was it meant to be sort of a little bit more broadly applicable like that?
Yeah, I think the difficulty level is for a beginner, and then as the beginner feels like they have learned some of the basics and they want to do more, there's opportunity to do more. So it's meant for anybody who is a beginner who wants to start something and start growing in the learning. It's also for somebody who's probably practicing it and then just wants to get a context of the technology in an application that's interesting. So it could be even for somebody who has some experience, and definitely if there's an expert, we're hoping they can take these ideas and use it in other application contexts, so they can understand maybe like we talked about the Nokovit processing pipeline, so maybe they can use it for some healthcare data processing pipeline. So maybe there's some expert who just wants an example to kind of implement a particular application, and one of the applications can maybe help them do that for another application. So we're hoping it will be for a range of people with different backgrounds. So there are some prerequisites, as we talked in the beginning. Hopefully when they go into the lab exercise, we have resources that if they don't have some of those prerequisites, they can go read up on it and still make progress. And as Songjie said, we have the Slack channel, and so we're happy to support people as they go through it if they have questions. And we will be posting some of the content videos for some of these topics also on the website. So we're hoping if they don't have the background, and there's plenty of resources for some of these concepts on YouTube and all that, but if they really want to do things hands-on, and like we said, some of the unique things we have are free access to some of the infrastructure and interesting integration with applications. So some of those things, as they try, if they can do it, that's great. If not, we are willing to help. So we're hoping it will be broader, and the goal is to make it as accessible as possible.
All right, thank you, Prasad. So Joe has a question. How are you looking to support this platform over multiple semesters? In other words, if a faculty member wanted to use this over the span of a full year, could they do so and plan on the resources? And also how to deal with the AWS costs, Google Cloud Platform costs, or PRP scheduling?
That's a great question. And the way I think of it is we're trying to do it firsthand. And I think anybody can do this. So the application is all containerized. So if a class wants to really host this in an institution, they just have to download, the containers, and they can set it up if they have infrastructure, they can set it up on whatever infrastructure. Right now, the way it is free is, again, we're using public cloud platform. So, we can work with the Nautilus team. I think they're funded for a few more years, for some of the Kubernetes. AWS provides AWS Educate, and now there's a new version starting January. I think it's called AWS Academy. So if you're an instructor at an education institution, you can set up your own instance, and you can be giving out your AWS Educate credentials to your students. So, and you can request several hundreds of dollars. At least in my classrooms, I use up to $200 or so for the students in a semester. So the AWS helps you do that through AWS Educate. Same thing for Google as well. If you're a beginner and you want to learn, they give you some free credits for a little while. So it's been our experience that if you're an instructor at an education institution, you will have the ability to work with some of these providers and maybe your teaching assistant to set up your own instances. But at least for the next year or more, we want to be able to host this and support anybody else who wants to come in. So as you saw in our software, we could make anybody an instructor. So if there are groups of instructors and students wanting to do this, we can approve them, and if the instructor contacts us, we can have them set up their own instructor role, and they can manage their students and look at their students' performance also. So we can add in kind of a filtering facility in the telemetry part we're talking about. So I think this could be done at least in the foreseeable future. But one of the problems that we've faced, and again, what we're trying to do is, if you have too many cloud platforms, it's hard for everybody to get familiarized with all of those platforms and be able to have accounts and know the functioning and working of all those platforms. So that could be nice for somebody who really wants to do it. But again, if just people want to just know the ideas, concepts, and the application context, and they don't want to deal with all these cloud platforms. So we're trying to standardize everything around AWS and AWS Educate. So that's another way we're kind of thinking. But that's a great question, and it's a real important question also. Like, how do we make it accessible to other instructors to have their own instances, and also how do we, over the longer term, ensure that we can manage the access so that students really are not burdened by the platform.
All right, thanks, Prasad.
Yeah, I can add one more point. Oh, sorry.
Oh, go ahead, Songjie.
Oh yeah, I just want to add one point. For the public cloud platforms, AWS and GCP, they do provide support in terms of teaching model. So if you are a professor wants to create a classroom for these DevOps, it's you can easily apply for a credits to host a classroom setting for free. So I've seen many faculty have been doing that.
All right, thank you. And then I have one last one, and I'll remind everybody again, if anybody else has any questions, please type in. So let's say somebody does experiment with this and tries it out, either with students or just on their own. Via your GitHub page, is there a way that they could submit their own exercises or their own experiences to make this larger?
Oh, that's a great question. So that's the whole point of what we talked about in the platform sense, is there is ability that Roshan showed in his demo. If they are wanting to contribute new content or make a particular module, a variation of that, they can work with us. We can give them instructor role, and then they can actually basically go through a wizard and add new content cards that could be available to everybody. So there is that extensibility part. So it's actually pretty nice and easy feature to add new content. But obviously there are elements that you need to have in place to add that content, and there's a guide for that. But the hope is, it's not only these 4 modules, but there will be other modules, or like you said, somebody could make new contributions to existing modules, and we should have some coordination, obviously, but we can kind of keep improving this hopefully in the future.
All right, thank you, Prasad. Well, it looks like that may be it for the questions. So thank you again, everybody, for presenting. When you get a chance, please send along the slides. I'll make sure that those get shared along with the links to the various parts of your project. And we'll get this posted. And then for those that are still listening, let me see who's up next week. I believe it's going to be Brenna and Ed. Yep, Brenna and Ed from International Networks at IU, and they're going to be talking about the GNG routing working group and also using NetSage to help with performance debugging. So we'll make sure that we send along information on that, and hope everybody has a good weekend.
Yeah, thank you, Jason, for the opportunity. Really enjoyed it, and thank you all for listening and all the feedback. Thank you so much.
Thank you so much, everyone. Have a good rest of the day.